Okay, we're going to look at problem number 15 on page 513. And I'm going to show you some techniques of organization that will help you to solve these elimination problems maybe a little bit easier. So the first thing I want to do is I want to examine the factors of my equations when I have them in a format where I don't have rational numbers. If I have rational numbers, it just makes it a lot harder. If I can get rid of my rational numbers as coefficients, it makes the problems easier. So I'm deciding what I'm going to attack. Am I going to attack my v's or am I going to attack my u's? If I attack my u's, I have to make 15 my common factor for elimination. Or if I attack my v's, I have to make 30. So either one, it's going to involve a similar operation of sorts. So let's do this. Let's label this first equation A, and I'm going to circle it just so I don't ever confuse it with a variable. And the second equation is B. So what I'm electing to do first of all, since I'm going to eliminate using a common coefficient of 15 here, I'm going to take equation A and I'm going to multiply it by 3. So I'm going to say, what's 3A? Okay, so 3A, if I multiply equation A by 3, I'm going to get 15u plus 3 times 6 is 18v, and then 3 times 24 is 72. So now I have something that is starting to be workable. I'm going to look at equation B, and I see that let me multiply equation B by negative 5. And if you multiply it by a negative number right off the bat, and you just eliminate by adding, it tends to reduce the mistake. So I'm going to multiply 3 times negative 5, and I get negative 15 u. And I take 5 times negative 5 is minus 25 v, and that's equal to 5 times negative 5 times 18, which is the same as 10 times 9. So if I take 18 times 5, I take half of 18, that's 9. I double the 5, that's 10. And it's an easy way to find that this is negative 90. So what I'm really doing now is I'm adding these two up. And when I add these two up now, I eliminate the variable u. So negative 25 plus 18 is going to give me a negative 7v. And then I look on the right side, and 72 with negative 90 is going to leave me with a negative 18. Okay, so if I say negative 18, how about that? Negative 18. Okay, so I could do the work on the side, and I could say, well, 90 minus 72 is 18. I know the answer is going to be negative because 90 is farther away from there. So I'm left now dividing both sides by negative 7, and I can easily now get v is equal to negative 18 over negative 7, which just would be 18 over 7. So now that I have my v solved for, I will then search back and decide which equation is the easiest to deal with. Well, in this case, A or B, both probably are just as difficult to deal with. So I'm going to go ahead and substitute, and I'm going to go ahead and put it into the first equation. 5u plus 6 times 18 over 7, that's my value that I found for B, is equal to 24. So I do like to get rid of the rational numbers, makes them easier. We don't have to, but I think it's a prudent thing to do. Look for any reduction you could take, and if you can't find any reductions to take to make it simpler, then just multiply both sides by 7. So if I take that equation now and I multiply it both sides by 7, let's see what that does. Okay, so I'm going to multiply by 7 here, 7 here. I distribute the 7 to this first term, and I get 35u. The purpose was to get rid of this denominator 7. So I'm going to just say plus, and I really have to multiply 18 times 6. So 18 times 6 is 9 times 12. I know that from my multiplication tables, it's 108. And then 24 times 7, I could just go ahead and 7 times 4 is 28. And 14 plus another 2 is 168. So now if I subtract 108 from both sides, I can do that pencil work here. 108 from 168 leaves me with 60. So here I have 60, and so u now is 60 divided by 35. Now I can see I can reduce that. I have a factor of 5 in both numbers. So 5 comes out of 60, leaving me a 12. And the reduction here leaves me with a 7. So I contend then that u is now 12 over 7. Okay, so that's what we would do to solve that system by using the process of elimination. Okay, thanks.